Right, picking up a few more surds in the assess for chapter 4, page 45. 6 questions plus a couple exam style AQA questions. I'll just do maybe one from question 1. Which of the following numbers are rational and which are irrational? Well, let's look at this one here. I've got root 16. Root 16 over 7. Well, that's not irrational because root 16 is 4 over 7, so that's rational. I've got, next one is root 16. Actually, it's the root of 16 over 7, the whole thing. Root 16 over 7, which actually means root 16 divided by root 7, and that becomes 4 over root 7, and that's irrational because of the root 7, you see. Next one, do it down here I think, root 63 all over root 7. Well, I can convert that to the square root of 63 over 7. I think 63 divided by 7 is 9, root 9 is 3, therefore that's rational, believe it or not. And there it goes. Simplify the following surds. Well, I'll do the last one. This is 2e. I've got 2 lots of root 50. Better go yellow, I can't see it. Well, that becomes 2 lots of root 25 times root 2. Yep, root 2 times root 25 makes root 50. Taking it further, that gives me 2 times 5 times the square root of 2. Altogether, I've got 10 lots of the square root of 2. So 10 root 2. Express each of these as a square root of a single number. Okay, what does that mean? The square root of a single number. Let's just try this one. I've got, let's try the first one. I've got 2 root 3. If I go root 4 times root 3, I end up with the square root of 12. There you go, the square root of a single number. How's that? So I suppose you better do it that way. Let's pick up another one. I've got, not done one of these before, just picked it up first time. I've got 2 root 11, and the square root of 11 can't be done. Well, the square root of 4 is actually root 2. Oops. Square root of 4 times the square root of 11 gives me the square root of 44, and that's the square root of a single number. You see what I've done? I've taken the rational part, the whole number, the integer. I've found its square, and then put the root on it. So, and then combined it with the other surd. Right. So, well, that's the surd. That's just that's a rational number. And the last one, I've got 10 root 2's. Well, 10 squared is 100. So it's the square root of 100 times the square root of 2, essentially the square root of 200. Is that alright? That's that done. Question 4 wants me to rationalise a few bits and pieces, and it's claiming it's A star. Alright then, let's just do a boring easy one. 4 over 2 root 5. Well, the way to destroy root 5, you just multiply by root 5 over root 5. Multiplying across the top. In fact, why don't I cross out the 4 and the 2 straight away? Just simplify that down a little bit. So that's 2 over 1. Back to my yellow. Right, root 5 times 2. 2 root 5. Square root 5 times square root 5 is the square root of 25. Take it further for the final step. I've got 2 root 5 all over 5, and that's it. That's fully simplified. Let's do one of these really scary ones at the bottom. And let's go for, again, I don't know how it's going to work out. I've got 7 over root 3, take away root 2. I think this lot is sort of A level. Now, to remove this one, I'm going to multiply top and bottom by 1, which is going to be root 3 plus root 2 divided by root 3 plus root 2. Oops, one little root there. Bracket that off for the minute. Bracket that off for the minute. That divided by that is 1, because I'm dividing my 2 the same. Putting it into the top, I've got 7 lots of root 3 plus root 2, and underneath I've got, open my bracket, root 3 minus root 2 multiplied by root 3 plus root 2. Got to multiply all this out. Let's go yellows. Right, top bit, no change there. 7 lots of root 3 plus root 2. I might deal with you later. Right, root 3 times root 3 is root 9, otherwise known as 3. Root 3 times root 2 is root 6, plus root 6. Root 2 times root 3, again, it's going to be the minus root 6 because of the negative just there. And minus root 2 times root 2 is minus root 4. Tidy it up a little bit. I've got 7 lots of root 3, 3 plus root 2. Underneath, my root 6's disappear because it's plus and minus. Back to yellow, I've got 3, take away the square root of 4. The square root of 4 is 2, so 3 take away 2 is 1. Final answer, 7 root 3, of course multiplied, and root 2. Alright, and no point multiplying out, that's simplified enough, and that's fully rationalised. There's no denominator, well, denominator is 1. I'll leave that one alone. I'll do question 5, I don't think I've seen one of these before. I've got to write it, let's have a look, I've got to write this thing, root 2 plus 3 squared, in the form of a plus b root c. Right, these three numbers are integers, so I've got maybe like a 2 root 5 plus something. The a could easily go at the end, so it can be b squared root c plus a, makes no difference. But I'm not going to be intimidated by that. I'm just going to multiply this out and see where it goes, alright? I mean, there's no choice in the matter. You've got to have a go. There we go. And then we'll demystify this mysterious algebraic expression. Right, root 2 times root 2. Again, you don't really need to do this, but I'll do it anyway. Root 2 times root 2 is, of course, the square root of 4. Square root of 4, which is, of course, 2. And root 2 times root 3 is going to be 3 lots of root 2. And this one now, 3 times root 2. Another 3 lots of root 2. And the square root 3, sorry, and 3 times 3 is 9, so add on 9. All together now, we've got 2 plus 9 is 11. And 3 root 2 plus 3 root 2 makes 6 lots of root 2 altogether. So here we go, let's just demystify. That is my A, 6 is my B, and the C is my 2. Alright, so that's written in the form of, put a little box around that one, that's written in the form of A plus B root C. Okay, that matches that requirements of the question just there. Alright, that didn't hurt much. Should we do another one? What looks really scary? Well, I'm going to do one more, can't wait forever. I'll do this one then. I've got 1 plus root 2 multiplied by 2 minus root 2. It's really just the terminology. Write this in the form of A plus B root C. Looks scary, but it's not, you know. Let's just do it the normal way. 1 times 2 is roughly 2. 1 times minus root 2 is minus root 2. Root 2 times 2 is plus root 2. Root 2 times root 2 is root 4, but it's negative, minus root 4. Tidy it up a little bit. Let's just get rid of my root 2's. What have I got? Minus 1 root 2 plus 2 root 2's. Can't get rid of it completely. So I've got 2 there. Minus 1 root 2 plus 2 root 2's is plus a sinc root 2. And root 4 is 2, so it's take away 2. Now we can do some simplifying. 2 take away 2 is 0. And I'm left with good old root 2. It can't be that easy. Written in the form of, okay, fine, well, C is worth 2, B is worth 1, and A is worth 0. Better just write that down again. Look, it's plus nothing, so A must be 0, B has got to be worth 1 because it's 1 lot of root 2, and C has got to be 2 itself. Alright, very strange, that really threw me. Right, question 6 looks very interesting. Again, I've not tried it out, but I fancy doing it, and so let's do it together. Question 6 on the assess page 45 says that I'm given this. I'm told A is root 2, B is the square root of 8, and C is the square root of 12, and I've got to work out C divided by A minus B. and I've got to simplify it as well. So let's just take it as far as it can go. Right, shove some numbers in there. I've got the square root of 12 over root 2 minus root 8. Well, where can I even begin with that one? Rationalise it? Don't know yet. Maybe I should. Let's just rationalise it. How do we do that? Multiply by root 2 plus root 8 divided by root 2 plus root 8. That should rationalise the bottom nicely. Multiplying across the top. Just take a good look at this one, shall we? Root 2 times root 12 is going to be root 24, and that's going to be plus, what have we got? Root 96. Yeah, I mean, maybe I might have to go back and simplify it later, but let's just do that for now. Here, root 2 times root 2 is root 4, that's 2. Root 2 times root 8 is root 16, so that's plus root 16. Root 8 times root 2, that's going to be minus root 16, and let's extend it a little bit. Root 8 times root 8 is going to be minus root 64. I've got a feeling I shouldn't have done that bit, but anyway, I'm going to keep going and see where it goes. Alright, it's just an experiment. Right, what have I got underneath there? Well, this is beautiful, isn't it? I've got 2 plus 4 minus 4, and the square root of 64, of course, is 8, so let's just take away 8. What have we got then? We have got I better just simplify actually. Let's go back to where I was before. So I want to go root 12 bracket root 2 plus root 8 divided by, let's just take over here, 2 plus 4 is 6, take away 4 takes it back to 2, so 2 take away 8 is minus 6. I'm sure I can simplify root 12 like this. Root 4 times root 3, all multiplied by root 2 plus root 8, divided by minus 6. Well, root 4 is of course 2. Let's do another step. So it's going to be 2 root 3 multiplied by root 2 plus root 8, all divided by minus 6. Let's just take another page over this one. What have I just got now? 2 root 3's multiplied by, I've forgotten, root 2 sorry, it's a multiplication, oh dear, just get rid of that. That should be multiplied, so I want a bracket there, really. Too many roots in my life. Right, root 2 and root 8, okay, so multiplied by root 2 and root 8. We're dividing that by minus 6, so here I go, divide that by minus 6. Straight away that's a third, so let's just go further. That's going to be root 3 multiplied by root 2 plus root 8 all over 3, and the whole thing's negative. Alright,